Howdy! Welcome to another episode of Dinosaur Parkour. Faster, better, mainframe programming. The topic of this video is Edit Macro DISP1ST version 2, 3, and 4. Improving the code using REXX. I got several requests to teach REXX recently, and that is why there will be 3 additional versions of the DISP1ST REXX in this video. I also want to mention that I think I found the DISP1ST REXX on the internet or from a magazine many years ago. I used it at my prior place of employment. I'm unable to credit the original author for the idea of the DISP1ST edit command since that version is no longer available to me. I'm your host, Chris P. Fried. In another video, a piece of JCL was edited and a series of edit commands issued to make a change. Then those edit commands were coded in an edit macro. Line 11 is the only logical control in this exec. It is a very basic edit macro. With the exception of line 8, all the lines were explained in the other video. In this video, the code is going to be improved by making it handle DISP OLD. 3 versions will be shown to demo how REXX logic can improve this macro. The original code is in the first member, DISP1ST. The cursor is beside version A. There are 2 additional versions that end with B and C. The one that ends with Z is a backup of the original. Press enter to edit version A. This is version A. It accepts a Parm of either old, share, or nothing, which means news share. So line 8, which was not discussed in the other video, needs to be discussed. When writing an edit macro, macro has to be the first command past the ISR edit. It has to be the first edit command. Several REXX statements can execute prior. The argument on the command line are passed to the variable str. Line 9 uses a short form of translate. Only the target string to be translated is passed. The to and from translation tables are not passed. When that is done, translate converts lowercase alphabet to uppercase alphabet. Line 10 through 17 is a select statement which validates the input Parm. Line 11, if Parm string is null, default it to the value of SHR, which is short for share. Line 12, if the value is share, continue. Line 13, if the value is old, continue. Otherwise, show an error message and exit. Exit 1 means successful completion. The value of 1 tells the system to put the cursor on the command line. The remaining lines were discussed in the other video. Let's compare these lines to the original version. The hard-coded disposition value of SHR for share was replaced with the variable STR. The variable is colored green in the new code shown in the top half of the screen. Line 23 uses a concatenation operation. The 2 vertical bars mean string concatenation without spaces. However, REXX supports automatic concatenation, and line 21 and 24 are taking advantage of that. The lack of spaces between the double quote and the variable str is important for those lines. DISP1ST version A is shown on the command line with nothing after it. If enter is pressed now, a null string is assigned to the str variable. Or share can be typed afterward and cause the macro to do the same thing, which is to change the DISP =share line. To change the DISP OLD line, the macro has to be run again with the parameter of old. Press enter and the 2 lines with DISP OLD were changed. The disadvantage is having to remember to run it twice. This is the second version of the macro, version B. It basically just duplicates the DISP share line for the DISP OLD. Line 12 through 17 handle DISP share. Line 16 is interesting because it changes DSN to be ZDSN. That was done so that line 23 does not change the DISP equal share lines again. This is a neat technique. If a change command messes up a prior change line, consider having the prior change do a work in progress change. That is what line 16 is doing. It is a work in progress change. Line 20 through 24 handle DISP equal old. Line 27 changes the ZDSN back to DSN, which completes the work in progress chain. Line 28 exit successful. The 1 means place the cursor on the command line. Notice the formatting of the two if statements. If statements in REXX handle a single statement. To have the if handle a series of statements, a do end block has to be used. It is a personal choice which technique to use. I tend to code 21 through 24 because it looks more like a COBOL if India, but many programmers prefer to line up the do and the end as shown on line 13 through 17. Let's run the B version and see what it does. Press enter. It handles both the DISP equal share and the DISP equal old line. This is version C. It uses a REXX subroutine which is being invoked as a function. This is the version I intend to implement and keep. Line 20 through 23 are basically the same lines used in version A, where an argument was passed from the command line. However, a quick glance at line 8 tells us that an argument from the command line is not used. Lines 18 through 24 are a REXX subroutine. Subroutine can be invoked as a call subroutine or as a function. Line 10 and 11 are invoking move disposition as a function. The procedure tells REXX that variables used in the subroutine are to be in the subroutine namespace. To word it another way, the variables in move disposition are locally stoked. Basically, move disposition cannot access the CHG variable on line 10 and 11. The STR variable can only be accessed by the move disposition subroutine. Line 19. Arg is short for parse upper arg. It converts the argument values to uppercase. That bit me in the butt many years ago. I had a REXX that identified obsolete DB2 bind. It was passing the con token around, and I accidentally used arg when I should have used parse arg without the upper option. Some folks refuse to use arg because that implies convert to uppercase behavior. For the purpose of this code, arg works. The lowercase o on line 11 becomes uppercase O in the move disposition subroutine, which is required. Remember the work in progress changes used in version B? That is avoided this time because line 23 includes the space just prior to the DSN equal. The goal is to place the disposition before the DSN equal. Once lines have been changed, the leading space is no longer there. Thus, the future invocation of move disposition will not impact lines that were previously changed. Because the move disposition subroutine is being invoked as a function, the return instruction has to return a value. Line 21 returns 0 if nothing was found to be changed, whereas line 24 returns 1 because changes were made. Line 10 simply accepts the return value in a variable named CHG. Line 11 is a tad more interesting. CHG gets assigned a value from the match function, which returns whichever value is higher. The value from the invocation of the move disposition function or the current value signed in CHG. Why? Line 12. If no changes were done for both the DISP equal share and the DISP equal old, the ISR edit reset command is issued. Line 13 uses exit and line 24 uses return. If line 24 uses exit, this exec stops running. Control goes back to the panel that invoked this edit command. Line 24 and 21 must use return to pass the value and give control back to line 10 and 11. Line 13 can use either exit or return. Exit was coded so that I can point out the differences between exit and return. To use COBOL lingo, exit is kind of like stop run, and return is like go back. Exit means quit the REXX exec. It is mostly used to quit if a critical error is found and it's not okay to continue execution. If I wanted to make move disposition bulletproof, it would validate the value in STR variable. This shows what I mean. Line 25 uses exit because a critical error was encountered. It does not make sense to return from this subroutine since STR contains an invalid value. So it issues an error message and quits the exec. Whereas return is used when processing needs to continue. Let's run version C. DISP1ST is on the command line. Press enter. It changes both the DISP SHR and the DISP OLD lines at the same time. There you have it. 3 improved version of the DISP1ST edit command. I hope you have learned more about how to use REXX and to make your programming activity faster and better. This has been another episode of Dinosaur Parkour. Faster, better mainframe programming. Thank you for listening. If you're not already a subscriber, there should be a subscribe icon on the screen. If you found this video useful, please consider becoming a subscriber.